Bonding.
Oh my god.
Ionic bonding. Two atoms of different electronegativity come together. A valence electron transfers to the more electronegative element. An ionic bond is formed. Covalent bonding. Two atoms of similar electronegativity come together. Neither one can steal electrons, so they share electrons, forming a covalent bond. Metallic bonding. Metals have a sea of electrons, which join the positively charged metal nuclei together, forming metallic bonds.
Introducing Leo and Rigbert to explain octets. Leo and Rigbert are octopi that are out buying drinks. Leo got 10 drinks, which left Riggy with only 6. Leo realized he couldn't carry all the drinks and Riggy didn't have enough. They decided to help each other out. Leo gave up 2 of his drinks to Rigbert, leaving them both with 8 drinks.
Octets. Every atom wants to have 8 valence electrons in their outer shell to become stable, hence fulfilling the octet rule. For example, chlorine has 7 valence electrons and wants to gain 1 electron in order to fulfill its octet. Sodium, on the other hand, has 1 valence electron and wants to lose that 1 electron so that its next lower filled shell will fulfill its octet. However, there are a few exceptions. One being boron, that only needs 6 valence electrons to become stable, for example in boron trifluoride. Another example is sulfur, which can take on more electrons and still be stable. In sulfur hexafluoride, sulfur has 12 valence electrons that will occupy its D shell. Just remember that CNOF will always obey the octet rule: carbon, nitrogen, oxygen, and fluorine.
Lewis structures. To draw a Lewis structure, draw dots around the atomic symbol to represent the valence electrons. Oxygen has 6 valence electrons, so there are 6 dots. Mg has 2 of them, but Mg2+ has no valence electrons. Atoms have the tendency to have 8 valence electrons in their outer shells, so when 8 or no dots are around an atom, it is satisfied with the octet rule. When sodium and chlorine come together, an electron transfers from the sodium atom to the chlorine atom. Then, Coulombic attraction binds the 2 atoms together. With SO2, the atoms have to share. Each atom has 8 electrons around it, so the molecule is stable.
Sometimes when we draw a molecule, there are multiple ways to draw its dot structures. For example, with N2O, we have 3 dot structures. These different structures can all occur, so the actual structure of the molecule is a mix of these so-called resonance structures. In order to determine which one of these structures is the most probable one, we use the method of formal charges. Formal charges are the excess charges that would be present on atoms if electrons were split evenly in all covalent bonds. So if a nitrogen would be bonded to a nitrogen like this, you think of the nitrogens having 2 electrons between them, one of which would be in the vicinity of one of the atoms and one would be in the vicinity of the other. So if we look at these resonance structures, this nitrogen has a formal charge of 0, this one has a formal charge of +1, and this one has a formal charge of -1. This one has 1 more electron than usual, so it has a formal charge of -1. This one would have a formal charge of +1, while the oxygen would be left with a formal charge of 0. And this atom would have a formal charge of -2. This one would have a formal charge of +1, and this one would have a formal charge of +1. So how do we decide between these resonance structures? As formal charges attract each other, minimizing the magnitude and number of formal charges makes a more probable resonance structures. So as this molecule has a formal charge of -2, and there are formal charges on all molecules, this structure is not probable. To decide between the remaining resonance structures, we need to consider the electronegativities of the atoms. It is probable for a negative formal charge to be on an electronegative element like oxygen, so the first resonance structure is the correct one.
Formal charge. This is the general equation used to calculate the formal charge in atoms in molecules. V is for number of valence electrons, N is for the number of non-bonding valence electrons, and B is the number of electrons in covalent bonds.
Here we have carbon dioxide. The oxygens are double bonded to the central carbon atom. Each oxygen has 2 lone pairs of electrons. When plugging the numbers into the formula, we find that both oxygens have a formal charge of 0. The carbon atom has a formal charge of 0 as well. The total formal charge is 0, which is perfect because it matches the overall charge of the molecule.
It's going to be the hot.
Ionic bonding.
To get the rest of us. Lewis structures. For example, here we have chlorine with